finally, we want to talk about asymptotes. Okay, asymptotes. Okay, so we didn't really talk about this too much last time, but we did see an idea how does this asymptote look like. That is, your graph, as I said the last time, if you remember, your graph will approach to for a certain line, a certain value, you might say, but it will never cross that. Okay, if you remember, for 1 over x squared, your graph approached very close to this y-axis or even this x-axis on your right and left, but it never really crossed that or nor even touched it. Okay, so this line, which is, this is x equals 0, right? We know that this line is x equals 0. This is an asymptote. This line y equals 0, this is an asymptote as well, only for this guy, 1 over x squared. For this function, this rational function, this green line, x equals 0 is an asymptote. This blue line, y equals 0, is also an asymptote. Asymptote means your function, your graph, will approach very close to that, but it will never cross it. It won't even touch it, okay? As you can see that. So that's how you can define an asymptote in English. In maths, it's quite similar. As you can see it, if you have 4.3 open in front of you, the PPTX file I'm talking about, you can see we can have, different types of asymptotes. But for this section, we'll have only 2 types, horizontal and vertical. We also have another type of asymptotes. We won't talk about that here. Maybe you'll see that in Math 181 or 127, maybe, I'm not sure, but at least not in this section. So the horizontal asymptote, as you can see, the horizontal line like x equals 0 could be defined as a horizontal asymptote, and the vertical line y equals 0, it's a vertical asymptote. That means the vertical line where your graph will approach, but it will never touch or cross it. Okay, as simple as that. Okay. Now, we want to locate asymptotes. That means we want to calculate asymptotes. Where is that? Where can we find an asymptote for a particular graph? So for rational functions, we'll actually have asymptotes. Can anyone tell me why is that? Can you imagine why can you expect an asymptote for a rational function? Anyone? Just give it a try, even if it's wrong, no problem. No, doesn't matter. It doesn't need to stay above 0 because for the last problem, I guess it was 1 over x squared minus 2. The last problem we see yesterday, the asymptote was actually here. The graph looked like this. So it can stay below 0 as well. No problem with that. The asymptote was actually at y equals -2. Anyone else? Forget about the graphical interpretation. Just think algebraically. Can you imagine anything that that might be a reason behind having an asymptote? Just give it a try. Okay, no problem. So the reason is, now it will make sense hopefully. So if you have a function like this, obviously I'm talking about rational functions. Let's say ax over bx, where ax and bx are polynomials. Just clearly think a value of x which is making this undefined, okay, or which is making this entire, or even this, a value of this could give you something undefined. values of this. Okay, but in general, the denominator, you can easily find one or two values of x for which the entire fraction will be undefined, right? Now, graphically, that means what it means by undefined, that at that point you don't have a defined value. At that point you can't have anything, any point, any line, any curve, any part of your graph which is defined. That's why we can expect an asymptote for a fraction. Can you see that? Because at that point, like for this one, for y equal, okay, that means the graph will never meet the undefined value. Yeah, of course. That's why we say it's undefined, because you can't really define that either algebraically or even graphically. You can't really define that. That's why we say there is an undefined thing. That means we can't really reach there, or you can't really go there. You can't have anything there, etc., etc. Okay, like for this one, for y equals -2, our entire function will be undefined. So it can't really go beyond that. And for x equals 0, that means this line, it also becomes undefined. That's why this graph, as you can see, will go very close to these two lines, y equals -2 and x equals 0, but it will never touch nor it will cross that. So for a fraction, it's quite, expected. You can easily expect one or two asymptotes, because for any value of x, or even for the entire function which is making our function undefined, we'll have an asymptote. Okay, it doesn't necessarily mean that you will have asymptotes only for fractions. You can have asymptotes for other different functions as well. We'll see, hopefully we'll see examples like this. Okay, so first of all, as I said, now we want to calculate, and we don't want to graph it. Even without graphing, we want to calculate where is our asymptote. Okay, and for that, we want to first take one example. Then I'll say the shortcut and the explicit way as well. Okay, so for the vertical asymptotes, let's say we have let's take one example. Let's say I have a rational function. Let's take one complicated one so that you can work on the easier ones. I'll take this complicated problem. And of course, I'm looking for the vertical asymptote, okay? That means this type of lines, vertical. Okay, and in the denominator, we have x squared plus 2x a minus 35, okay? Okay, so as I said, we want to calculate the vertical asymptote. That means we want to find the value of x. Well, I'm showing one by one. I'll show horizontal asymptotes as well. I'm showing it one by one. I don't want you guys to see too many things on a single frame. First, I'll show the vertical one. Then after I finish that, I'll show the horizontal one as well. Okay. So the vertical asymptote is, you just need to find the values of x from the denominator, which is making your function undefined. That means which is making this denominator 0. Okay. So first of all, we'll try to see whether we can simplify this entire function or not. This will make our life easier. Let's try that. I can write x squared minus 5 squared, right? I can clearly write this 25 as 5 squared. And I can factorize this, right? So all I'm looking for is the sum of 2 and the product of -35. So it will be +7 and -5, right? I think so. Yeah, this will give me +2 and -35 as a product. So I can actually write x plus 7, x minus 5 in the denominator after I factorize it. In the numerator, if I use the formula for the difference of the squared, you have seen this in Math 95. You can write x plus 5, x minus 5, x plus 7, x minus 5. Thankfully, we can simplify it further because this can be cancelled. Okay, so finally, we'll have x plus 5, x plus 7. And as I said, we want to set up our denominator to 0 and find the value of x. So x plus 7 equals 0. X will be -7. That means for x equals -7, we'll have an vertical asymptote. As simple as that. You need to set your denominator to 0 and solve it for x. Whatever you get in return is your vertical asymptote. Any question from this? Take a look at this and try to not only -7, it's actually x equals -7. The entire thing is the result, not -7, because only -7 doesn't really make any sense because you need to show for which value it's actually about, or it's actually an asymptote. So -7 means it's somewhere here, -1, 2, 3, 4, 5, 6, 7. That means it's actually here. It will be at -7, a vertical line like this. Yeah, obviously you have to write like this. For vertical, you need to write x equals something. For horizontal, you need to write y equals something. Because as I said, it will be a vertical line like this, where your graph will approach something like this, but it will never touch or cross. Okay, you need to write it completely. If the denominator was x plus 7 at this start, you will instantly know that it was -7 by eyeballing it. Yeah, of course. Yeah, of course. Okay, so I can show one example like this. Let's say this one. Why don't you do the x plus 5? That's the numerator. So the numerator, if the numerator is 0, that doesn't make my function undefined. Only if the denominator is 0, then my function is undefined. My numerator can be 0, no problem with that, because you can actually divide 0 by some value. But you can't really divide anything by 0. This is undefined. Okay? Does this make sense? Okay, very good. Now, I'll show you one more problem. Before that, let me just show Pearson. Let's say we have a problem like this, okay? X plus 3, x minus 3. Okay, let's say that's my problem. Let me say that's f of x, okay? That's my f. So if you have a problem like this, straight away, you can eyeball and say, hey, x equals 3, from this is my vertical asymptote, okay? If you already have a simplified, if you have a function which is in the lowest terms, you can always eyeball it and say straight away that this is my vertical asymptote, okay? But first of all, you want to write it in the smallest form, okay? This will be a lot time consuming, but you need to write that in terms of the lowest terms. Otherwise, as you can see, if you keep like this, if you set this to 0, you will actually get two results: x equals -7 and x equals +5 as well. But as I said, let's say this. If you set that to 0 straight away without writing in the lowest form, you will get two results, which is wrong. X equals positive 5 is not at all a vertical asymptote. So that's why you want to write the function in the lowest terms first, then set your denominator to 0. But if it's already in the lowest terms, then you can always eyeball it and set your denominator to 0. Okay. Okay, now I'll show one more complicated problem from the vertical one, then we'll go for the horizontal. Okay, let's say we have a function like this. Okay, let's try this. X squared plus. Okay, now what should we do? By just eyeballing, can you think of any way that you can do, we can use here, which will be really helpful? Can you think of anything, any way, any technique by just eyeballing? Don't look at the answer. Good try, but you can't really rewrite x squared plus 9 as x plus 3 and x minus 3. You can't really rewrite it, sorry. You can't really rewrite, because it would have been x squared minus 9. Then you would have written it x plus 3, x minus 3. By using the formula of the difference of the squares, but it's a plus. You can't really write like that. No, it doesn't. Okay, let me show it here. X plus 3 times x plus 3 is actually this. X plus 3 the quantity squared, not this. So we can't really do that either. It's good you guys are trying it. It's really good. Okay, cross out x squared. Okay, how can you cross out x squared? Because you have another term associated with it. You can't really rule out that. You can only cross out x squared if you have that in a factorized form. If you have that in a single term, you can't really factor out or cross it out. That's another good try, because that's one of the common mistakes. All the three answers I have so far, these are the common mistakes. So it's good to know this. You know, it will be easier for you to avoid this type of problems. So first of all, you can't really simplify it anymore. This is the lowest term. Okay. So now how can I confirm that it's actually the lowest term? And for that, the three answers I have actually gives me an idea, because I can't really use this formula. This is not this formula either. And I can't really factor out x squared from the denominator either, because I have a plus 9. I can't really factor it out. So that means I can't really see any way how I can simplify it anymore. So this is the lowest term. So now next job is to set our denominator to 0, right? X squared equals 9. Now, how can we go further from here? What can we do further from here? Because you need to have the solo x, right? You need to solve it for x. Yeah, I can take square root on both sides. Definitely I can do that. But as you can see, because of this guy, I have a problem. I can't have a negative inside the square root, right? No, we are working with only real numbers. We would have tried 9i if we are working on the complex number or the imaginary number. But all we have worked on so far for both x and y's is the real numbers. We can't really take 9i here. Anyone else? You guys are doing really well. I can see you guys are trying. Okay, multiplying both sides by 1. Okay, let's try that as well. So this is not possible. Let us try next and see what happens. If we multiply both sides by 1, that doesn't really help because we still have a negative here. We can't really get rid of that. Can you see that? Exactly, Daria is right. We can't do anything else from here. We can't do anything else from here. So that means x, there is no value of x, as we can't really solve it for x. That means we can conclude that there is no value of x for which x squared will be -9. There is no value of x. Now, what does that mean? That's why I said it's complicated. It does look easy, but there is complications. Very good, Chris. So that means there is no asymptotes. Precisely, we'll say there is no vertical asymptotes here. Very good. Does it make sense to you guys? As I said, we need to find the values of x for which the denominator will be 0. But as we can see, there is no value of x on this occasion for which the denominator becomes 0. There is no value of x. That means there is no vertical asymptotes. Very good. Okay, any question from these vertical asymptotes? Because now we'll go to horizontal asymptotes, and there I'll show you 2 ways, one explicit way to calculate and one shortcut as well. I'll show you both ways. But first of all, let's make sure that we are clear about the concept of vertical asymptotes. Okay, so for vertical asymptotes, there is no real shortcut because as you can see, this is really a smaller calculation. This is really small. You can actually eyeball this. In most occasions, you can actually eyeball what's the answer. But for y, or rather for horizontal asymptotes, we'll have explicit calculation as well as I'll show one shortcut as well. If it's not there, I'm not sure whether the shortcut is there or not, but I'll definitely show it to you guys so that you can save your time, especially when you're doing multiple choice question. But if you are given a question where you need to show your work, then you can't really use your shortcut. Okay, keep that in mind. When you are said that you need to show your work, then you need to show it explicitly. But for multiple choice questions, you can use my shortcuts. Anyway, any other question from vertical asymptotes? We don't need to graph this, right? We'll come there. First of all, this is the problem where you don't need any graph. Your question will look something like this. Find the vertical asymptotes from these rational functions. Okay. If the question says something like this, then you don't need to graph it. But you might see question where you need to graph it. We'll see this later. So first of all, let's start horizontal asymptotes. Okay. Okay. Now, horizontal asymptotes, and for this, once again, we'll have rational function, and as I said, all of our ax and bx are a polynomial. So on this occasion, I'll actually write the polynomial format. Okay, so previously, let me write the previous format. So that was the polynomial, right? So the polynomial format of this is this, right? You have seen this before. an minus 1 x to the n minus 1 plus dot 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 plus a1x plus a naught, right? That's the form of polynomial. Same for b. We'll use m x to the m b m minus 1 x to the m minus 1 plus dot 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 plus b1 x plus b naught. So we already know this, but I'm just rewriting it in the polynomial form, simply because we'll actually need this value of m and n. Okay, the degree of each polynomial, we'll actually need that. Okay, let's start. Okay, so, oh, they have shown the shortcut. That's good, very good. I can see they have shown the shortcut. Anyway, I would have shown that anyway. So the degree of the numerator is n, right? You can see that. And the degree of the denominator is m. We will actually need this to calculate. So the idea is, if your degree of the numerator is less, that's case 1, is less than the degree of your denominator, then straight away, without any calculation, you can say that, hey, y equals 0 is your horizontal asymptote. Straight away. Okay, what's that? Temple Run 2? Shit. Okay, so if your degree of the numerator is less than the degree of the denominator, you can straight away say that y equals 0 is your horizontal asymptote. I'll just show the cases first, then I'll show at least one example of each. Okay, if the degrees are equal, then we'll actually take the ratio of the leading coefficient. Now, a quick question: what is the leading coefficient? Who can tell me? We have heard this word before. What is a leading coefficient? No one? Let's give it a try. I can't see any A here. There is no solo A here. I can see A's with different subscripts though. The first value, what do you mean by the first value? I can always rewrite the highest degree coefficient. Yeah, that's right. That means if you know where is your degree, that means the term with the highest degree, the coefficient of that term is called the leading coefficient. You don't need to have that in the first place. I can always rewrite a polynomial like this, right? But the degree here is 2 and the leading coefficient here is 1. If you don't have anything, you can always imagine a 1 there. So the leading coefficient is, of course, the coefficient of the term with the highest exponent. Okay. So as I said, if your degrees are same, we'll just take the ratio of the leading coefficients. That's it. This will be y equals, of course, y equals this will be your what I was talking about, vertical? No, horizontal asymptotes. Sorry. Okay. So this is actually the shortcut. I'll really try. Let me just give you a look. If you need to go for the explicit calculation or not, just let me check. If I can see that they haven't shown the explicit one, I would rather be happy to let you guys go, because if you can use these shortcuts and save your time, there is no harm in using that, because in maths we always believe in solving problems taking less time and with more accuracy, right? So if you can use these shortcuts, I see no harm. Uh, but let me just see whether they will allow me to do that. So chances are it could be a fraction for the horizontal. Yeah, exactly. It could be a fraction. It could be, definitely. But it doesn't necessarily mean it will always be a fraction. You might see a whole number here as well. But yeah, there are chances that we'll see a fraction. Yeah, good point. Okay, yeah, I think I can allow you to use these shortcuts everywhere because they haven't really focused on. I haven't finished it yet. I'll go to n greater than m. No worries. I'm just trying to find out whether they will uh, or whether uh, I should allow you to use this shortcut. I think yeah, that's okay. I'll allow you to use these shortcuts. I won't even show the explicit way. That will actually uh, blow your mind away. That won't really uh, be something really easy. That's a bit complicated. I don't want you guys to get that sophisticated feeling. I want you guys to use this with more accuracy. That's what I want. So yeah, I think that's it. I'll just show the shortcuts and you can use it everywhere. Okay, so next up, oops, sorry. If n is greater than m, then we'll say there is no uh, horizontal asymptotes. Okay, there is no horizontal asymptotes. But we'll have a different type of asymptote, which is the oblique asymptote. As I am not going to show the explicit way, I'll show you this thing. Previously, I thought I'll just show you the vertical and the horizontal one. But as I am saving your time by letting you use this shortcut, I'll now show the oblique asymptote as well. But first of all, does it uh, make sense? I'll show one example of it, no worries, but you need to remember this, okay? It won't be written anywhere. You need to remember this. And from my previous experience, I have seen students messing up this. They use the alternate uh, things that's written here. And that's quite easy, right? You can see there is a little room for error. If you make an error, you get a completely different result. So that's quite easy for n equals m, but for the inequalities, it's quite easy to make a mistake. So you need to remember this to the least, to say the least, okay? Okay, now, what's an oblique asymptote? So previously we have seen asymptotes as this, vertical like this, horizontal like this, but now we'll see an asymptote like this as well. Okay, that means if I just show a quick example, we will have graphs like this where your function will look like this. Okay, it won't cross this line, neither it will touch it. You can have this type of asymptotes as well, and these are called the oblique asymptotes. Okay, now when can we have this? After I show this, then we'll show, or rather see one example of it, hopefully. So if we have n equals m plus 1, okay, the degree of the numerator is actually one more than the degree of the denominator. Before oblique, how we were supposed to do without the shortcut? Sorry, I didn't get a question. Before oblique, how are we supposed to do without the shortcut? Oh, I'm oh, okay. So for the horizontal ones, I'm not going to show you the explicit calculation, because I think I can allow you to use the shortcuts, because the explicit one is sophisticated and it will actually blow your mind, because that requires you to uh, learn a different concept as well from the higher calculus class. So I was wondering whether they will allow me. So I just looked through the file, and I I think they are okay if we use the shortcut everywhere. Okay, but if you when you will move to math 181, you will see the explicit calculation for sure, because I was a TA for math 181 for the last 3 semesters, and I've seen the explicit calculations, so that will require you to uh, have more constants. Anyway, I can show that to you if you want, but yeah, they will definitely teach it, because as I said, I was a TA there for 3 semesters. If you want to know, I can show that now as well. I have no problems with that. But as I said, it will be complicated. And as I can see from the PPTX file, uh, they have just focused on the shortcuts as well. So that's what made me think, yeah, I think we can go for the shortcuts. They didn't really mention it here though, that this is the shortcut. They have kind of showed that this is actually the explicit way, but we actually have an explicit way other than this. Okay, and you can see this is actually shortcut. You can actually eyeball the answer. Okay, no problems. And again, if you want to learn that, we can talk about that as well. I have no problems, as I said. But let's see if we can finish this in time today. And then if we have enough time, then maybe we can talk about that. No, definitely in higher calculus. I thought so. When I saw the asymptotes, I thought they will show that here, but I don't see it. I don't see it in the PPTX file. You can see that for yourself. You can actually check the uh, PPTX file for 4.3, and you can see all they have shown, all they have focused on are this. Okay, they're focused on this three, and two more for the oblique. Okay, not two more, actually one more anyway. So okay, so for n equals m plus 1, we can actually say that this is the subdivision of this. So let's say uh, we can actually define this as 3a. That would be better, because for n greater than m, we can actually subdivide it into two parts. N greater than m plus 1 and n greater than m plus 2 or more. We can actually subdivide it into two parts. So that's for n greater than m, we not have any horizontal asymptotes. Yeah, we can say that. But if n is greater than m, and it's actually just one more, okay, not this, sorry, this should be equal. If it is this 3a, then we'll say we will definitely not have any horizontal asymptotes, as we can see it from here. Any n greater than m, we can straight away say that, hey, at least I won't have any horizontal asymptotes. But if the degree of the denominator is just one more than the degree of the numerator, or rather the other way, if the degree of the numerator is just one more than the degree of the denominator, then you'll say we actually have an oblique asymptote. We won't have any horizontal asymptote, as it's greater than the degree of the denominator. No problem with that. But will we have any other asymptote? And the answer is yes. We'll have an oblique asymptote. And what will be the asymptote? it will be y equals ax plus b. Okay, and this will be calculated from the ratio of the polynomial. We'll show examples of this hopefully. And as I said, 3b, if n is greater than or greater or equal, in fact, the degree of the denominator by 2 or more, then you can say that there will be no asymptotes at all. As it's greater than m, we already know there will be no vertical asymptotes. Oh, sorry, horizontal asymptotes. Horizontal asymptotes, but also there will be no oblique asymptotes either. So there will be no asymptotes at all. Now let us see one example of each, okay? But before that, what I'll do, I'll show one example of each on my right. And first of all, n is greater than m, but for a, n is equals to m plus 1, and for b, n is greater or equal m plus 2. Okay, now I'll show one example of it, and we'll see. Oops. Okay, let's start. So let's say I have a function like this, minus 2x cubed minus, minus x, and x to the 6 plus 4x squared plus 8. Okay, first of all, which one does it satisfy? Which of the category? Can you see that? So as far as I can see, the degree of the numerator is 4. The degree of the denominator is 6. So it's definitely this one, right? So we can straight away say y equals 0. As you can see it here. Where's that? Here you go. Y equals 0 is the horizontal asymptote. And if you have a graphical calculator, or if you can use online calculators, online platforms where you can graph it, if you graph this, you will see this graph will, from either side, this graph will never cross y equals 0. That means this line. This is y equals, let me use a different color. This is y equals 0. From either side, this will never cross it. You can check it for yourself. Okay. Okay. Now n equals m. Let's try one of these as well. Let's see. Okay. I think we can use a problem we have seen before. Let's try this. This one. As you can see, our degree here is 1 and 1, right? For both. That means it satisfies the second one. And let's try it this way. I think this looks very easy. Let's try this. 3x and 2x. Okay. And our degrees are 1, so it will be y equals the ratio of the leading coefficients. That means 3/2. And again, if you graph it, you will see 3/2 means 1.5. I think I should use a different place. Let me show it here. 1.5 is here. Let's say you'll see it will have a line like this, which the graph will never cross from either side if you graph it. Okay, so your first job after I finish today will be try and grab these examples and verify whether it actually looks like this or not, okay? And if you don't get it, you can send me emails that, hey, I'm not getting this, I'm getting a different result. Maybe you showed it wrong, or maybe I'm getting it wrong. Please help me, and I'll do that for you, okay? Now, what happens if we have the third case? Let's take this example. 2x cubed plus 3x squared plus 2, and x squared plus x plus 1, okay? Let's say that's our new problem. And on this occasion, our degree is 3 and 2. Can you see that? That means it's definitely n greater than m, no doubt about that. And this clearly means that there will be no vertical asymptotes, or sorry, I'm doing this over and over again. There will be no horizontal asymptotes, okay? As this is n greater than m, there will be no horizontal asymptotes. This is the first job you need to do before going any further. At least you need to make this conclusion that at least I'll not have any vertical, horizontal asymptotes. That's the difficult part of talking for over an hour, you know, often you get tangled and all that. Anyway, I hope you understand. So this concludes that we'll not have any horizontal asymptotes. But the next thing we need to check whether there will be any oblique asymptotes or not. Whenever we see this case, for these two, we don't need to check that. But whenever we have this case, we want to check that as we don't have any horizontal asymptotes, are we supposed to have an oblique asymptote or not? And if your degree for the numerator is just one more than the degree of the denominator, then we'll say, yeah, we'll have an oblique asymptote, okay? And we'll also see how can we calculate that. That's quite sophisticated as well, but we'll see that, okay? Okay, so first of all, which one is it? It's for this problem, is it A or B? Is it 3A or 3B? 3A. So clearly we'll say, hold on, we do have an oblique asymptote, right? We can clearly say that. So now we'll see how we can calculate this, because for the other one, we can easily say that y equals 0 or y equals the ratio of the leading coefficients, but this is not that easy. We'll soon see that, but let me just show one example of this before we conclude. We'll just take the same example like the previous one. Let's say like this, okay? It's also in this category. So you can straight away say that we don't have any horizontal asymptotes, no doubt about that. But as the degree is actually 2 more than the degree of denominator, so you can also conclude that we won't have any oblique asymptote either, okay? We won't have any oblique asymptote either. So that means there will be no horizontal, no oblique asymptote for this problem. Okay, does it make sense up to this? If yes, then we'll see how can we calculate this. Otherwise, we can answer questions. Okay, looks like you don't have any other questions. So as I said, in 3B, we can calculate the oblique asymptotes, or not for this one, sorry. We can calculate horizontal or rather oblique asymptotes by just taking the polynomial division. So that means we need to divide this first. So What is the problem? Here you go. 2x, let me rewrite it here. 2x cubed plus 3x squared plus 2 over x squared plus x plus 1. Okay, so that's the fraction, and we need to divide it. That means x squared plus x plus 1. If you remember, we have learned this in Math 95. This is 2x cubed, oops, plus 3x squared plus 0x plus 2. Excuse me. If you are wondering why did I write this 0x, if you remember from Math 95, to keep the consistency of the powers, we want to do this. As you can see, the power of x is 3 here, there is 2 here, so we expect something of x to the 1 here as well. As we don't have anything like that, we can always write 0 times that, because 0 times anything is 0. So in that sense, we can actually maintain the consistency. Anyway, so if we divide it using Math 95, I would recommend you guys to go for the result of this. If you can't do it, go to Math 95 and check, or rather try to refresh your memory. Hopefully that will help. If you can't do that, we can discuss it next time. But for now, I hope, I believe that you can do that. And if you can do that, finally you will have a 2x plus 1, and you will have a remainder of this. Okay, so that means if my function, let's say g of x, initially was 2x cubed plus 3x squared plus 2 divided by x squared plus x plus 1, it can be written as 2x plus 1 plus a negative 3x, so on, the remainder over the divisor. Okay, if you remember, that's completely from Math 95. If you don't reach this stage, even after refreshing your memory from Math 95, don't hesitate to poke me. Okay, I can show that to you. Okay, so that's the function. We can actually rewrite it. And now for the oblique asymptote, we'll actually will you see this type of example on the homework or quiz? Yeah, as I'm showing this, you will definitely see maybe one example, one problem like this. Okay, I'll definitely see. I'm not saying that I'll definitely give this, but you can expect to see this type of problems because I'm showing this taking a lot of time. Anyway, so if x tends to infinity, that means if we plug in infinity in place of this x's, this will be 0. Okay, and that's one of the explicit calculations I was talking about. Okay, how can we do that? Why are we doing this? This is difficult. So for now, we just need to remember anything, any number over infinity is 0. Okay, you can approximate as 0. So if you plug in infinity here, okay, it will be the entire function will be 0. So this g of x will be close to this 2x plus 1, and that's the oblique asymptote. So that means whatever you have which will tend to 0, we say in maths that it tends to 0, that means it will go close to that but not quite. If you find a point like that, then this is your result. That means you need to plug in x equals infinity and negative infinity, and if you find anything that makes your entire fraction 0, the other part is your answer. Can you see how complicated is that? I know it looks very clumsy. Okay. So first of all, using Math 95, try to find the final result. And from this, if you plug in x equals infinity, that means if your x tends to infinity, if you get 0 for any particular fraction, the other part will be your answer, because as x tends to infinity gives you 0 for this, then your main function will tend to the other part. That's the idea. I know this looks clumsy, but try to see this video over and over again, and you can try one or two examples from the book as well. If you don't have any other example in the resource 4.3, you can go back to your book, you can see one or two worked out examples and try one or two exercises as well, okay? And if I am kind enough, which I am really, I'll try to avoid this type of problems, but I want you guys to learn. That's why I won't say that I'm not going to give this type of problem. I'd recommend you guys to practice problems like this. I'm not sure whether you can see examples on My Math Lab. I'll always recommend you guys to go back to your book, because I'm repeating myself, your book is your best friend. You should see worked out examples from those, and you'll have plenty of examples, I assume, which you can practice. Anyway, so let's just quickly talk about the test and the quiz. So as you know, I think your next exam is on Wednesday, right? Or is it on Thursday? Let me just quickly check. Thursday, yeah. Okay, thank you for confirming. So we'll have a review session on Wednesday. The entire Wednesday will be for review. And for the test, I guess one of you asked how many questions will be there and or rather what will be the duration. So first of all, I haven't really set up the question as yet. I'll probably do that during this weekend. Once I set up the question, I'll update you with the time it will be available, the duration it will have, and if I have any other announcement to make, I'll let you guys know that as well. For the quiz, you'll have your next quiz on Monday. It will be on 4.1 and 4.2. And I'll set up the question tonight. So once I set up the question, again, I'll let you guys know when it will be available, what will be the duration, etc., etc., etc. But for the quiz, you definitely will have a time between 2:30 to 3:15, probably 2:30 to 3 p.m. It could be either of these two. I'll update it. Don't really rely on this file.